Well, welcome everyone, both those in the room and those participating with us virtually. Thanks for attending our Friday talk here for the SE department and co-sponsored by the INCOSE Rams group. So thanks for the involvement for today's meeting. Decide to advance. Our agenda for today, we're going to share a couple highlights from the recent INCOSE International Symposium that was held a couple weeks ago. And then Dr. Bradley's going to speak on the topic of what makes a good research question for all of us that are in the process of developing our questions for either a thesis or dissertation or still iterating on those. And then I'm going to give a talk on security-focused system goal elicitation. And then we'll have potentially time for any questions about the above. So first thing, just wanted to re-highlight, what does INCOSE Rams exist to do, right? It's a student organization in which we want to help further the art and practice of SE and academia, industry, and government, right? While promoting research and producing solutions that meet needs. So if you're not participating with it, we've got a Teams page out there. Is probably the best way to participate. You can join that team, get some notifications of INCOSE Rams events, pushing out some good information about INCOSE events in general, and a forum mostly to be able to connect with both fellow students, but also with representatives across academia, industry, government that may assist you where needed. So upcoming INCOSE events we like to highlight. The nearest of those is the Western States Regional Conference. That's going to be held in Richland, Washington in September. Those call for papers was closed, and I know we've got a few from CSU that are accepted to that. They are still looking for some student posters. If anyone has a poster they want to present or students that you want to push a poster to. And then the International Symposium, so the event we're highlighting that just happened in Hawaii, they announced that next year it's going to be in Dublin, Ireland. So be on the lookout for the call for papers for that. Typically that call gets released in the next couple of months with, I think, due dates are around the December-ish timeframe typically, or around the end of the calendar year for that event next summer. So this past event was in Honolulu here in mid-July. I was fortunate enough to be able to attend along with quite a bit of other CSU students and faculty. So some of you may have noticed, as I did myself, and this was Dr. Bradley's photo, but CSU was doing a lot of advertising in the airport as well. So you may have been greeted with a nice advertisement banner showing the program while you're waiting at baggage claim. And then we also had an excellent opportunity, a networking event where we were able to bring together most of the faculty and students in attendance to get together and enjoy a little social hour at one of the local brewing companies there in Waikiki. So it was nice to be able to meet fellow students that are from around the United States or world that were in attendance, and they got to meet some of their professors and such for the first time. So that was an excellent opportunity to connect. We had, I think, 9 total presentations that were accepted for publication. Not going to read through all these, but if you know one of the authors, you should congratulate them, as this is the premier INCOSE conference and one of the premier systems engineering venues to be able to present a work. So it shows well on the students, the advisors, and the program, right, to have so many presentations and publications accepted at the event. So congrats to each of you if you're on the line for your paper presentation. And now I will turn it over to Dr. Bradley, and he's going to kick off what makes a good research question.
Thanks so much, Trae. Yes, sir. I have one more comment that I wanted to make before starting in on this topic set, which is just there's one other conference that's going to happen in the next couple of months, and it's everybody should anticipate we'll send out a call for posters. It's going to be the AIAA. It's called an annual technical symposium, and we're hosting it here on campus. And so for folks who are in the area or would like to come to campus, it could be a good opportunity to sort of network and do that sort of stuff. And we'll be asking and soliciting poster presentations for students to be able to talk to industry and talk to other students and professors about their work and such. So it should be kind of interesting. So keep an eye on your email for that kind of stuff. We'll certainly send it out through the INCOSE RAMs. Okay, so what I was invited to come and talk about today is to sort of try to define some some tips or some understanding to try to transmit some of my understanding about research questions. And so the general agenda here is what I'll just try to do is present, I think, a starting point, a kind of a framework that is how, at least I sort of think about research topics and questions and tasks and what are these and how are we trying to define and address them. And then I'll go quickly through the general idea of sort of defining research topics. We'll concentrate more on research questions, and I'll go quickly through how we sort of think about research tasks. So to put that framework into place here, I'll describe that, when we talk about research, and the definition that generally we sort of try to talk about with students is that research should be a systematic approach to the development of new knowledge. And when we think about systems engineering research or something like that, we talk about, our objective is of course to add to the systems engineering body of knowledge. So just generally tried to sort of illustrate that here with this idea that, we have this systems engineering body of knowledge, and this contains all the things we know about systems engineering. It's got all of our components like model-based systems engineering and requirements engineering and project management and blah, 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 all the things that we can describe as being the things we know how to do in systems engineering. And the big, our objective then is to try to expand that, to try to move what it is that we know further outward, to take over, to solve problems that we couldn't solve before, to come to some new understanding that is a theoretical understanding of what systems engineering should be doing, et cetera, right? And so I sort of define here that we will have, when we talk about research topics, what you're going to do is sort of define application domains or theories or frameworks within the systems engineering body of knowledge, at least overlapping with the systems engineering body of knowledge, in which you will be doing your work. And so those could be topics like, any of these that are a component of the systems engineering body of knowledge, but could be things like cybersecurity. It could be things like model-based systems engineering. It could be things like architecting, whatever. Those are all topics within systems engineering. So our charge then in defining research is to be able to sort of define a problem that is out, that we don't have the tool to solve, or we don't have the frameworks to be able to understand it, or we don't really know the answer again to that. And then what we do is compose and document those problems in the form of research hypotheses or research questions. I'm going to sort of try to concentrate on research questions in this discussion. But then what we do is we sort of say, all right, having now defined that our research topic is going to be at this interface between cybersecurity and model-based systems engineering, and we want to define this problem that we don't really know how to do model-based systems engineering with cybersecurity requirements or something like that. Okay. Now we're going to decompose that problem into tasks that we can actually execute to be able to come to new understanding, to address that problem. Okay, probably never really going to be able to solve that problem, right? I mean, that's a big ask, but can we advance our understanding of the problem enough to actually make progress? All right. So now, when we talk, I have another talk that I have given in previous year that was about defining research topics. And I would just sort of charge folks that if you're interested in this or want a more detailed discussion about this, you can go to the YouTube channel for Colorado State University Systems Engineering and watch what goes on there. But generally, when we talk about research topics and when you sort of think about what parts of the systems engineering body of knowledge would I like to make my contributions to, I said, you know, these should be aligned with your interests. These should be aligned with your advisor's interests. These should build off of things that you're actually good at and want to be doing. These should be things that, you know, you can make a career out of, or okay, it doesn't have to be career, but that you can actually make real progress against. And it should be off, you know, again, like ours is an applied discipline, engineering is an applied discipline. We need to make sure that it's responsive to actual need in the field or actual need in the domain. So, you know, I mean, just to a definition or a description of what my research topic of an example research topic might be, would be something that says like, yeah, I'm interested in model-based systems engineering and the application of space-based communication and network. And so I want to find something, you know, my goal, my topic is something that's at the interface between those things. This doesn't yet define like what's wrong or what the problem is or what it is that we don't quite know. That is what we'll define when we start talking about the research questions. So generally, I think when you talk about a research topic, you know, you should try to measure or understand whether your research topic can be mapped to or is in between some of these domains of research. We in systems engineering are lucky. Again, we give ourselves a broad license to be able to do in a variety of different topics. And one of those, you know, we can do research in basic engineering, which basic research, which is sort of the domain of theories, of frameworks. We can do research in applied domain, which is sort of where we study tools or methods or procedures of engineering, design, all that kind of stuff like that. Or in the domain of translation.
Yeah, he wants to be
where our objective is, maybe can you mute everybody? Yeah. Okay. Where our objective is to study the practice of systems engineering in the real world or something, you know, in its application. So the big idea is I try this. We could study engineering, you know, because we could redo research and find a research topic whose objective is to, you know, or that's at the sort of interface of defining what is technical debt in systems engineering, right? This is the sort of a theoretical topic. We're trying to come to some understanding, some framework that lets us understand what technical debt is in systems engineering as opposed to other domains. We could compose a research topic that is an applied research topic. It compares requirements engineering procedures as applied to system safety problems, right? So again, in this case, this is some interface between system safety and requirements, and we want to understand like what are how does the procedure A and B and C all compare? And then, you know, we can also compose translational research problems where we're actually studying, in this case, you know, requirements engineering in the application of this ATO process, and our objective is, but it's very applied, right? I actually want to look at what people, you know, are actually writing and see how effective it is. So, okay, so now the big idea is that by defining this research topic, we then can be more specific. We can start to advance research questions. And the purpose of, oftentimes, again, the purpose of research questions when you're doing your things like your preliminary examination, or when you're talking to your committee, or when you're talking to your advisor, the purpose of this is to be able to define and to organize and communicate these problems that you are going to try to address through your research. And in general, yeah, these should try, you know, again, if the objective is communication and the objective is definition, we're trying to take, okay, if you wrote this in a literature review format or something, it'd be a 3-page description of what is the problem set. And in a research question, we're trying to compact that. We're trying to make it so that it's very clear, very communicatable, readable, definable, arguable, what it is we're trying to do. And, you know, in general, the big idea is that these should be sort of, you know, I described it in that previous diagram, that those these research questions are sort of, you know, a definition of what the problems are. And it's common that in a single PhD or in a single master's, you might try to answer a couple of research questions. You might try to have a couple of defined contributions to the field. And they can be, they should interface. They can make, they can build on each other. They can add to each other, to all these kind of things like that. So I just sort of exemplified that a typical research question, a research agenda for a dissertation might have a definition of the potential solutions, an assessment of those, solutions in a computational format, and then maybe a demonstration in an example, in a real world example in practice or something, right? So when I think about some tips for what, can make effective research questions, I usually find most students sort of define their question or their problem too big. You sort of say, well, I've got this, I've done all the literature review, and it turns out that we need to figure out how to architect AI systems engineering systems or something like that. Like, yeah, that's true. That is totally true. But is that the kind of thing we can actually do in a couple of years? It might be pretty tough, right? So maybe instead of trying to define your problem to be the architecting of all AI systems, instead, let's sort of say, no. All right, look, that's where we want to be in 5 years or 10 years. How do we compose a 3-year project that we can actually execute? In that case, you might say, oh, in fact, let's, compare what should a research question is sort of like, what should be the architecture of an AI system versus something that's more focused, maybe more achievable, is what are the metrics that we might use to evaluate architectures for these things? That's a question that seems like you could actually get some answers to, right? And in this case, sort of defined it with real, metrics and objectives and stuff like that. Another tip that I sort of have that I think that people often miss or something is it's good. Again, I sort of said that this is supposed to be a communication device in these research questions. So I encourage folks to embed things like your methods or the modes of assessment or something like that in your questions. And making them specific allows you to communicate more clearly with your committee and do all that kind of stuff. But it also makes it so that when you come out of your discussions, when you come out of your advisor meetings, that you have a well-defined problem, right? You have a well-defined sort of domain in which you're going to do your work. If you're not specific in your research questions, then it can lead to crosstalk or miscalculation or all this kind of stuff like that. All right. And then, yeah, I apologize, got a little hanging on there. But, so here's an example of the kind of thing you could do. In general, research questions use what we call inductive research methods, and that just means that they're data driven, right? So as opposed to hypotheses, research questions are sort of data driven. So we're looking in a research question for a data point that we can actually use to make some conclusion about the benefit or cost or whatever of a proposed process. So here's an example research question. It says, in what ways does further decomposition of a computerized actuator design problem improve the design process for some space plane, whatever it is, okay? So the idea here is that this question has, it's defined what the problem is. The problem is that we don't know what level to decompose this problem. Should we define it at very high level? Do we need to define every screw and every bolt or something like that? What are the costs and benefits of doing this? And so if you think about composing, again, this research question, I hope it aligns with many of the previous advice I kind of gave you, that it's got some application in here, et cetera. We could sort of define, you can anticipate what the answer might be. That we would do a computational multidisciplinary analysis and optimization. And when we decompose it at low level, we get one answer. And when we decompose at high level, we get another answer. And the low level decomposition gets us an improvement, but it's more costly. It takes longer. This is sort of again, it's leading towards all this is in shorthand, but it kind of leads towards the type of answers that you can anticipate out of your research questions. So these research questions are posed at the beginning of our research agenda, and then the answers kind of come as we complete the research tasks. Also, it's important to realize and to plan for what the research contribution will be. And what that really means is this is now a definition of that new knowledge, right? We talked about that the research is going to be the systematic process to develop new knowledge. Well, now I can anticipate what that new knowledge is. And in this case, I've been able to identify some new trade-off that says, oh, if I put the compressor here and the heat exchanger there, it gives me a better result than it would otherwise. So another example is, can an MBSE tool capture information content for this architecture relative to a non-MBSE tool? And I've put in here explicitly like what the assessment will be about. What are we going to try to measure? We can answer that. Yeah. By doing this process, by measuring where the architecture content is, you can see that we have captured it better in MBSE than in document-based systems engineering. And what that gives us is again, sort of evidence now that we have more abstract knowledge, more high-level knowledge than it would be captured in document-based systems engineering tools. So I urge folks, as you kind of compose these research questions, to sort of think about what are the types, what are the types of ways you're going to evaluate these? What are the types of ways you're going to solve the problem? We'll talk about that and we talk about research tasks here in a second. But the big idea is that if you can kind of plan this out, even if it's sort of conceptual, then we can understand what it is that we'll be able to do as we move through the research process. So in a proposal, in any one of our proposals that we have to do for, asking for funding from industry or government or whatever, we have to decompose these research problems, these research questions into tasks. And the idea is that this gives us a concrete description of what kind of methods we're going to use to answer those research questions. And luckily, again, if we were doing this work in, civil engineering or something like that, I don't know, then perhaps, again, the number of methods, the types of methods that would be admissible methods for performing civil engineering research would be less. But we're lucky. In systems engineering, we draw this broad picture, this broad barrier around the field. And we love multidisciplinarity, and we love working with people who are from different fields and all these kind of things like that. So we allow ourselves to think very broadly about what are the types of tools that we can actually use. So I highlight tons of them here. I won't read them out, but the idea is that, again, we can decompose these research questions into research tasks that guide us step by step from, step 0 to being able to actually have the information we need to compare, to realize an answer to our research questions. All right. So, I'm trying to kind of go fast and make sure I don't take up too much time, and also leave a little bit of time for Q&A at the end and everything. And, but let me give you the big summary here. In my opinion, again, this is, developing research agendas and sort of thinking about R&D and thinking about how to solve problems. This is a skill set, and it's the skill set that's like one of the most fundamental skill sets that we're trying to train people in graduate school, right? And so it's something that it means we have to talk about it out loud. We have to talk about what works and what doesn't work. We have to talk about where our programs succeed and where they fail. And with the idea being that by talking about it out loud, we can sort of share our understanding and share what works and what doesn't work. And we can develop this as a skill that we all are continuously working on together. If our objective is, and it should be, this is the reason to go to grad school, right, is that we want to build ourselves a career in R&D. We want to build ourselves a career in innovation. We want to do this activity for the rest of our lives. Then we need to make sure, we need to understand that developing the research agendas and research plans is something that's just fundamental, right, to being able to do that work. But my last point here is that, it all looks kind of cute or whatever when it's in circle diagrams and arrows and all that kind of stuff like that. The reality of it is that research is a difficult and uncertain and risky process, right? And sometimes stuff works and sometimes it doesn't. And I would say almost every dissertation I've ever been a part of has parts of the program that just didn't work. It's fine. It's like, it's not inadmissible. That's not crazy talk or something like that. But what it means is that, we need to, is that we're all, we need to accept that as part of the research program. We need to make a good plan, but we also need to make sure that we're not constrained by our plan, even as we're learning new stuff and as we're working hard on this. So I sort of say out loud, the person who will be your primary resource, the best person to help you do your work, the person who knows your program best is your advisor. And so just all students should make sure that as you develop these plans, as you go through version 17 of your research plan or whatever, those conversations are one that are enabled by, enriched by your conversation with your advisor. So make sure that you've got she or he in the loop. Last thing I'll sort of say is, we have this talk is one of a variety of resources that we try to develop in our department to be able to support students to develop their research agenda. For those students who are in the Doctor of Engineering program, we have a class that's CC 710 that's called Innovation and Leadership or something in Systems Engineering, and we talk about developing research agenda in that. The PhD program, we have a class that's called Research Methods in Systems Engineering, and we go through the exact same sort of procedures and have much more in-depth conversations about these kind of things all over the course of the semester. So I would urge folks again that it's normal if you have, you don't have to come into our program with a defined research agenda. That's something we should be working on together and working with your advisor to be able to develop. So, so take advantage of those resources. I'm also glad to talk in general about this, and even I think I've got a couple minutes for Q&A. So thanks a bunch all. I'm grateful for your attention, and I'll be glad to take some questions. Maybe there's some stuff from online too. Let me know. Any rebuttals or whatever? Have other folks have input or experience? Aaron being quiet is pretty pretty out of character.
May I ask a question, Dr. Bradley?
Of course.
Maybe it's out of the scope of your presentation, but I am also always wondering if you have an idea or if you have a research topic in your mind and you do literature search and you don't find anything, it seems that it is all new. Can you just touch on that a little bit?
Yeah, right. So this is it's sort of a philosophical problem, right? Like, how do you show that nobody has ever done what it is that you want to do, right? I mean, it's like the answer is, like, again, philosophically, you can't show that. But so how can you show that? I mean, so you need to demonstrate to your committee and to your audience that your work is novel. And so what are the ways that you do that? I mean, what you can do is you can refer, for example, to review articles. Review articles will often call out what a research agenda in your field is going to be for the next couple of years. You can also do things like, show that people are solving this problem, but they're not really solving it using the same techniques that you think will solve it better. There's kind of on and on. So there's no easy answer to that kind of question, but the way that you do it is by demonstrating your complete understanding of the state of the field and communicating that to your committee and to your audience. And when you do that, then what you do is you're building trust in that audience that, in fact, yes, you do have a novel problem and you do have a complete grasp of what is the state-of-the-art problems in the field.
Thank you.
I'll answer the question that came in on chat, like, how involved is your committee in formulating your research questions? In my opinion, the primary person who is going to be your champion, the primary person you want to have in the loop is your advisor. And they know your field best. They know you best. They know your strengths and weaknesses best, all that kind of stuff like that. So I always recommend that you should primarily, your primary resource for composing your research problems and stuff like that should be your advisor. Now, I think it's good policy to reach out to your committee before you do your prelim exam and, talk to them about your problems. Oftentimes, your committee might have some specialist expertise that you want to take advantage of. In a typical PhD committee, 3 of the 4 people will be in the systems engineering department. So they're going to be really excited about the things you're doing. They're going to say, oh, yeah, but have you read this new paper that came out last week or whatever? They're going to be a resource for you. So I think you have to have some agenda. You have to have some vision of what you want to do before you go to the committee, or else the committee will just advise you. And that's not what you want. You don't want to have 4 advisors. So I sort of recommend, work those things out in detailed conversation with your advisor, and then take your vision to your committee. And I think that you'll have that'll be the basis of a constructive conversation with your committee. Any other questions or things? I would just go ahead, Aaron.
If you're a funded graduate, that means you probably have a limited ability to pick your topic. But within that, do you think that you should still try to phrase their topic, or you should try to restate your topic?
So ideally, I'll repeat the question perhaps for folks who are online. The question is, oftentimes we have students who are, funded researchers, that they have a graduate research assistantship or something like that. And the question is, like, how much freedom do you have to really define your problem? And should you, do that? My kind of take is that this is a conversation and a negotiation that you should have with your advisor. You want to come up out of the PhD process with this skill set of being able to define research problems, of being able to build a research agenda, to be able to write proposals the year after you graduate and stuff like that, right? So you should be as engaged as possible with that process. For some students, and maybe it's for master's students, you just probably won't have the time, and you won't have yet, I don't know, whatever, the expertise or something like that to be able to really engage fully in that. But I would urge you to think hard about it and to talk to your advisor about those kind of things. For some people, and for a PhD student, my recommendation, what we do in my lab group is, okay, like your first couple projects are going to be things that you've got to do. And then as we start getting more mature, as you start writing papers, as you start getting a better sense of where the field is, you start getting excited about these kind of things, then we can kind of flip the bit to where, you can actually participate in ideation, and we can start writing proposals and do those things. And again, train to be able to get the skill set that you need coming out. So, no easy answers there, and every advisor has their own agenda and opportunity space to be able to do that kind of thing. But I say out loud again that that's something that I think every student should be conscious of, is you want to be as engaged as possible in that. And I think most advisors will be responsive to your excitement about it, and make as much room as they can for people to be involved. All right. Well, again, I'm grateful for the opportunity to be able to speak to you all. Reach out, tell me if there's things I can help on any of these fronts, and glad to be able to talk to the INCOSE Rams group. So thanks.
Thank you very much, sir. We appreciate it. I propose for those in the room, go ahead and get some pizza, right? And I will not be offended as I start the background on the next talk if you are grabbing pizza and eating it. So. So for the next piece of our discussion today, I'm going to be chatting with you about some work that I am doing towards my own dissertation here on security focused system goal elicitation. So this work, Dr. Daly is my advisor, and Gabe Salinger is also a lieutenant in the Air Force. I'm a major in the Air Force. We're both full-time students. He's been doing a piece of this project with me as well. But if you look at the problem introduction space, and I won't spend too much time here, but in general, the shift in mechanical to software-based functionality increases the opportunity space and the vulnerability space, right, for the impact of cyber with respect to security in our cyber physical systems, right? And using cyber physical systems broadly, but more focused in this work is looking at complex systems related to primarily automotive and aviation is our primary application space we're looking at, right? Vehicles, airplanes, weapon systems, things that are relevant to the DoD. Also, my research group does a lot with heavy vehicles, right? Trucks, similar overlap in interest area there. And those communities, right? Another point is they've acknowledged this need and they've created these information sharing groups, right? These ISACs that they come together and host summits and attempt to share information to improve best practices in designing secure systems. And then you've got government regulation hand in hand with that, right? That the government has realized this is a problem for many of the things that they spend billions and billions of dollars on annually in developing, designing, fielding, sustaining, right? That previously we've had kind of a checklist approach for security. If any of you work with the risk management framework, though it's not actually designed to be a checklist approach, in implementation, it often is a select n number of controls from NIST controls available and potentially applicable to your system. And the wrong thought is that if you do all those controls, you have a secure system, right? We as systems engineers and looking at this with a systems thinking perspective can understand that a blind application or a lowly informed application of controls to systems that are very different in their design and operation and their emergent properties likely does not result in a secure system then in the same application of some standard controls. So there are a fair amount of, as Dr. Bradley, I've walked through part of the process that he's describing, right? That I said, well, this is my problem space. Then how do I go from that problem space to somewhere I can contribute? Well, as I'm exploring the literature, there's quite a bit of people who propose different methods for doing security analyses, right, on systems in design, development, fielding, right? But what I noticed a common thread among them that I'll get into is very little of those are applicable in the conceptual design phase, right? Pre-system architecture, where, as we know from some best practices in SE, that is our largest trade space, right? For implementing differences in that system with minimal cost and schedule impacts, right? If we can make design decisions in the conceptual design, those are the easiest to carry through with the minimal cost constraints comparative to being in the validation stage and doing operational testing on a system and going, we didn't realize that this is like an insecurable feature, right? Or this is a huge vulnerability in our weapon system. The GAO office, right? Report to Congress here. You could go and read this one if you're interested in weapon system cybersecurity, but I'll highlight here that this guidance states that cybersecurity requirements should be treated like all other types of system requirements. And I was enjoyed to also find out in a presentation at the International Symposium in INCOSE, right, that INCOSE's vision for 2035, in fact, quote, says cybersecurity will be as foundational a perspective in system design as system performance and safety are today. Right, so the community is making positive efforts in this area, but the amount of tactical way or methods to achieve said efforts are limited, right? Or there is a need there to continue to advance the state of the art in practice and achieving said objectives. There's a good presentation on stakeholder alignment on security needs, right? That and this work contributes there that you need a way to get the stakeholders to see the value in making security decisions in that early design. The NIST 800-160 is an excellent source that talks about this in a loss focus space, right? That protection, that we should look at security as what can we not afford the system to do, right? Or not afford it to, not afford to lose in the operation of said system. And you can look at an older report, right? 1972, unless security is designed to be in a system from its inception, there's little chance that it can be made secure by retrofit, right? That was reported back in the 70s. And we're still learning that lesson today. I'm not going to go through these in detail or present my literature review in detail, but if you're interested in some of the sources or areas where I'm looking for where we're sourcing some of this material, this is that list. Also, I'd love feedback if you're listening to this presentation today and you said, I've seen something like that, or I've seen something you should read based on that. Please email it, drop it in the chat, whatever it might be, because that's the stage I'm at in my research as we talk about the questions of make sure that I'm not missing something that could contribute to this. But here's my current attempt at the research question that this presentation covers. This piece is how can secure system design be improved through early system security goal elicitation? Right, so going to look, show you an example of what we're proposing in this space. So if we're trying to frame where is this problem space, that in conceptual design of our system, so on the left side of this V, after it's kind of towards the end of stakeholder needs, but certainly I've inserted this system goals, right? So you traditionally in INCOSE technical processes, right? 15288 business mission analysis, stakeholder needs and requirements, and system requirements definition. So that translation between the stakeholders to some specific system requirements. This fits in the middle of that, or kind of towards the beginning, right? That in helping refine the stakeholders' needs into a set of security goals or initial security related requirements. So I've looked at some of the best practices, right? And those of you in the automotive space may have seen this 21434, the road vehicle cybersecurity engineering document that was just published, I believe, last year, right? And they actually do a pretty good job of helping the engineer think about security as a part of system design. However, where I note a bit of a deficiency is they talk about the concept phase of system development. And they, if you would kind of expand that from the item definition, you would look at developing these cybersecurity goals, doing threat and risk analysis methods, okay, which is good. However, when you go to start that in the item definition, it has this thing that says preliminary architecture, right? So, and then this is what they provide actually as an example, you know, that this is at the start, right? So 9.3. That's where they say preliminary architecture, which is before you get into the goal development. But my question, and where I'm framing my research around, what if I don't have this level of preliminary architecture? What if I am just with a set of stakeholder needs and a ConOps or OpsCon that relays those needs, and I want to do some security goal generation, right? Where I do not know, and in fact, I'd be limiting myself if I had this specified level of how the system operated. Right, these are already form level physical decisions of what components would be in my system. As we know, as systems engineers, we want to maximize our functional analysis and functional look at the system before we start making form decisions. So rather than thinking we have to wait to cybersecurity until we get to a form, what could we do in the space where we just have some stakeholder needs? One of these other best practices we looked at is this new model called MBSC-SEC, where it's model-based systems engineering implementation of security analysis. But similarly here, and I apologize, this slide did not look like this on the other version of this presentation. But let me highlight for you here that they talk about starting with security requirements, right? And they do that, but how do we get these requirements? Well, as they state in their own documentation, is ideally engineers who are working in the security requirements engineering should combine expertise essentially to write these requirements. Now, of course, you know, they've got iterative loops as any good systems engineering method graphic should, right? That they talk about the iteration, and, you know, if they were hearing this presentation, they say, oh, well, we'd iterate and go back to them. Certainly, but you have to have a starting point. And their starting point, it merely says, essentially get your SME expertise as a starting point for your security requirements. Well, what is out there to help guide that discussion, right? Guide the interaction between the SMEs, the stakeholders, and what system documentation we have, so we don't rely on just this one person's best guess at what they think are initial requirements to go into said process. So this is what we've come up with, right? This is our figure depicting the process I'm about to walk you through here briefly. We're starting with the starting point of this is the stakeholder input in OpsCon. Then we walk through a path here to get to some initial security goals. And really, I got some good feedback on sharing this, that the goals, once you see them, they're not security only, right? Or security specific, but they are system goals through a security lens, right? Which is actually what we would want to see at this phase, that as we're looking systematically and we're wanting the system security security requirements to be treated on equal footing with performance and safety, such that we don't want just a subsetted list that only respect to security, right? We want these to be system goals that take into consideration how we have a secure implementation of these stakeholder needs, right? In that fielded system. So for this example, what we're looking at and what we're doing is let's take the challenge, right? Because I think this method would work best. We've talked about it works best on things that are not yet designed, right? Or things that are not yet fielded. So we kind of created this sample problem space that we want to have some off-road navigation that for those who live in a mountainous space or in the desert say, I want to get on the other side of this peak, right? And there are no roads that go there. There are some systems that are somewhat doing this. DARPA has a project they're looking at autonomous driving type system, but still out there in the conceptual space of what if we look at this navigation system as our SOI that would help me by means of its own onboard sensors, ingesting map data, right? Any other things that we can think of, it will create a routing path as my best way to get my vehicle across terrain from point A to point B. So that's what you'll see in the examples that we carry through, that's the system in which I'm demonstrating what this method might look like. So first step is to define the system purpose and goals. This came from STPA or largely adapted from them. And I think it's an excellent way to take 3 sentences and summarize what your system is set to do, primarily from a stakeholder perspective. That in one sentence, this a system to do what? Several verbs, right? Early level functions by means of. So we want a system to provide eccentric navigation guidance through outdoor natural terrain that lacks pre-established path by means of navigating, communicating, and sensing. Why, right? In order to enable transit across untamed terrain that lacks pre-established paths. You could think of many applications, right? If those of us who are off-road enthusiasts might think this is fun. If I just came from Alaska there, a trip in Alaska, and that's actually legal there, of the wilderness is the wilderness, and you can go across any part of it that you can feasibly navigate. Those of you in Colorado know that's not the case here, right? In the snow it is, but in the summer you've got to stay on a path, right? And take that path and follow all its regulations. But you could certainly see military applications of said feature that in some wartime environment, you want to get to point B and you don't care how you get there, but you need to get there. So you can start with this BDD to help visualize this. Then I think the next thing is we need to understand the context of the system, right? That let's understand where my SOI, right, this navigation sits in respect to, we're not talking about the entire vehicle design here. We're not talking about the controls of said vehicle. We're not talking about the satellites that may be controlling it, sending in inputs, whatever that might be, but it's part of this domain of untamed outdoor terrain, which, oh, by the way, has obstacles, barriers, wildlife, man-made features, right? Other people that may be friendly or unfriendly, weather. So we go from that to then a top level use case. I think any good system development, if you looked at all the different MBSE methods, you've got use cases in there. So let's develop a use case for this system with the stakeholders and identify our key actors, our key secondary actors, and our top level use cases. But then if you're familiar with STPA, you'd see that the system losses is a concept they use. But one of these in NIST 800-160 has been pushing for this as well. Is one of the best things we can do in helping design a set of constraints or requirements on the system is get agreement among the stakeholders of what can they not afford to lose in the system operation. Right. So in this case, you look at something like, I can't afford for it to kill people, right? Injury or death. I can't afford to lose my vehicle from the navigation system failing. And I can't afford, in some scenarios, maybe I can't afford to not be able to get to where I'm going, right? If you're thinking more of a militaristic application, like the system's got to be able to get me a route there. I don't care if it's a dangerous route, but, so balancing these losses. Then what you do is say, okay, well, I have this set of losses, but what are system states that paired with environmental conditions could actually lead to one of those losses? So this mapping helps demonstrate this a little better, but it's not the giant boulder field, right? That's not a system hazardous state. Okay, that's an environmental condition because you may be in a place that has almost no pass through it, right? But a misinterpretation of the terrain, that is a hazardous system operating state, such that if the navigation system is not able to accurately read the dimensions of the boulders in the way, right? Or ingest that data off a map to see that there are 30-degree slopes and I've said I can't traverse over 30 degrees, right? That is then a hazardous system state that when paired with those environmental conditions of large boulders or rain, right? That your vehicle can't cover that terrain, that could lead into injuries, right? Could lead into the loss of the vehicle. It could lead to mission failure. Right, so we've created this mapping between the two, and I've got another way to show this mapping as well that's a little more clear. But we go through and we try to exhaustively enumerate with the stakeholders all these hazardous states, right? To include ones like exposure of sensitive information under the wrong conditions. You can certainly see in a militaristic application, like, I don't really want to share my location when I'm not trying to get shot by bad guys who want to find me out here, right? That's exposure of information. But on the developer side, well, I don't want to expose my IP, right? Like I don't want the ability for people to take my algorithm or proprietary information off of said equipment, right? Because that is a loss to them of losing their proprietary set of way they navigate. And then the next thing we do to further iterate brainstorming, if you look to the initial thing, we've kind of got these parallel structural definition and behavioral definition. Is we take the top level use case we originally had and we make it a misuse case diagram. So if you're familiar with these, essentially we're adding an attacker or a malicious actor to that use case and trying to brainstorm at a very high level here, how might our system be susceptible to exploits or attacks related to confidentiality, integrity, and availability. Right, which are just big top level categories in security, right? That we generally think about CIA, but just ways to guide the understanding. This is not intended to be a fully enumerated vulnerability list or attack tree, right? There are a lot of methods out there to do full set of attack look at, but this is more an ideation tool, right? To sit down with your stakeholders or SMEs in the room and generate a few ideas about what things might be related and relevant to the security of the functionality so that you can update your losses, right? So that you can update your hazardous states and such that you can go to our next step, which is doing some high-level activity diagramming, right? So let's take all of those top-level use cases and let's make a high-level activity diagram for them. Within that, we've also proposed that you identify some security critical functionality, right? That you say that, hey, the validating authenticity of external connections, that sounds like security critical functionality. Let's highlight that for a future look, which you'll see in the next slide. Or hey, receiving data from the satellite, that's pretty security critical, and that we've got to make sure it's the right satellite, right data, and that we're able to receive it and process it correctly. So what we do then next is verify that the security critical functionality is addressed with our initial set of goals. So this, I realize, is the first time I'm showing you some of the goals that we've generated. Most of, in fact, all of these 7 were generated just from that hazardous state analysis, right? Or that use of losses and hazards helps create, you can create simple constraints on the system to bound your system out of those hazardous states. So that was our step 1 in security goal generation. But then we take a look at these activity diagrams. It's something we labeled security critical functionality. And our hope is that we pick it and we look at our goals we've got and we're like, yeah, one of them covers it. Well, in our example use of this, we had this authenticate user. None of the 7 or 10 goals that we had come up with so far really addressed that, we felt. So this was a good time to say, well, here, now we need to add a security goal with respect to user authentication and authorization, right? Because we've identified some functionality that we think is critical to the system. Again, all at a very conceptual level, let's add a new security goal that addresses that. So it's a bit of verification of are my goals sufficient to what I understand of the system functionality so far? And if not, a good way to then generate an additional goal that's tied directly to that functionality. So this was the set of initial security goals that we generated for that sample system. I'm not going to read all of these out, but I explained how we got the first few, and then the latter few were related to looking at that secure functionality we identified. Are these intended to replace or to be a fully specified set of system requirements for security? No, right? These are intended to inform, right, the next pieces in that system design process, to inform the development of the preliminary architecture such that we have a set of functional goals for the system that have been developed with a security lens, right? Or some specific goals that are respective to security for that system design. So they help guide that development and the decision making. And then I just wanted to highlight here too that I think the use of MBSE as a part of this process is one that we've seen pieces that were only MBSE or only not using MBSE, right? But I think it adds a nice link between, you know, some structural methods of looking at security, document-based type methods, and then, you know, the model-based systems engineering approach that combining the tool allows us to use features of the tool, right? Where we can do these matrices to see like, hey, is every critical functionality satisfied by some requirement? Oh, it is. Or this one, sorry, was showing, are all of our hazardous states directly tied to a loss? Or do we have some gold plating, right? Of thing that shouldn't be a hazardous state just because it doesn't create a loss. But yeah, we can look at these critical functions to goals, right? And say, yep, we have a security goal that covers each of the critical functionality and should help us design for that security of that functionality. And then we've got these requirements. We could look at our requirements to the hazards here as well. So all these goals or requirements we've made, do they address one of these hazardous states and preventing it? And which ones prevent and which others? So what needs does this work meet? Here's what, we said that it's a method to help guide elicitation of early security goals. STPA has showed promise in some of this, but its adoption has been a challenge, particularly in MBSE. What I've seen in the research and going and using it myself as well is people will create an entire custom profile in MBSE, which doesn't then translate to your actual model. But here we've used normal model elements, right? Use case diagrams, block definition diagrams, minimize the amount of custom profiles such that it should be easily integrated with your traditional system modeling. And I've kind of talked about some of the third bullet, but it helps focus future traditional design process. And then the last one is really also helps inform your OpsCon development. So we called that an input in this process, but it also is iterative, like, I don't know, go back to those, any good SE process, right? That it helps the stakeholders refine their document. As you're having these discussions with them, they can refine their own system documentation as they're learning through this exercise of what they actually really wanted. Who and how executes it? This was a question came up with a reviewer at INCOSE I talked to. I think this is the SE team's responsibility, but it's informed, significant stakeholder involvement and informed by the right SMEs and owners of pieces of either the system process or the contractors that are able to support, right? You've got to get better the representation in the working group, the better the product that you could generate here. So this is an attempt to propose a method to create these consolidated system goals with a focus on security for cyber physical system development used in that conceptual or pre-architecture design phase. So with that, I know we've only got a couple more minutes or like a minute left in our assigned block. Thank you to everyone for attending. What we will do, I saw some of the notes in the chat and wrote my own note of, we'll figure out how to get these recordings posted in our team, in our INCOSE team for anyone who missed it or anyone who wants to rewatch it. Probably rewatching Dr. Bradley's part, right? Is that's really useful to all of us in developing questions. But we'll also post a copy of the slides. My contact information is there. I'd love to have offline chats with any of you who are really interested or knowledgeable in this field as I'm iterating on my own work. If you want to get involved with INCOSE Rams, please see that link to the team and come in and help participate. We want to solicit more of these type talks, right? So lead by example, me on the leadership team of, I put myself out here to present what my work is for some feedback. We'd love for more of you to do that. It's okay, depending where you're at in your process. If you're early on, want some feedback, great. If you're ready to defend, we'd love to have you present to the community here as well, a shortened version of that, because I think we all benefit from hearing each other's research. So with that, thank you all. And I will not be offended for anyone signing off, but I will go ahead and pull up any of the questions and we can talk through those. If anyone wants to come online, you can do that too.
All right, thanks so much, Trae.
Yeah. Rock, are you still online? I can pull up my research question for you.
You.
Sorry, I'm getting there. Here you go. I think this chat out of the way.
It was good. It just, you kind of went into that next view before I could really look at it, but that's fine. I would have probably done the same thing. So I'm not critiquing, it just helped me like see what you were asking and then kind of reviewing what you did at the end. So that was good. So thank you.
Yeah, no problem at all.
And I'm good. I appreciate that.
Yeah, well, thank you for the follow-up, and yeah, anyone else? I'll go ahead and sign off the group one here, but if you want to talk to me at all, you've got my email and I'd be happy to have any further discussions. Thank you. Have a great day.